Hi, my name is Maeda Hanafi, and I'll be presenting our work on a machine-assisted error discovery approach in conversational AI systems. IBM Watson X Orders is an AI-powered voice agent that takes orders from drive-thru customers.
Sweet. What would you like to order?
Could I do a quarter pounder?
Watson X Orders currently takes 87% of orders on average without crew member intervention. However, we want to do better and automate more order-taking sessions. We need to eliminate errors that happen rarely, but often enough to significantly impact key performance indicators or KPIs. An example of a KPI is escalation rate, or how often sessions are escalated to crew members. The data triage team is responsible for finding errors that impact KPIs. Firstly, the data triage team searches for patterns of suspicious events by examining application logs. Then they formulate a hypothesis of the error so that they can mine similar suspicious events across several sessions. Finally, they estimate the impact of the error by calculating the escalation rate where the error pattern is present and compare that with the escalation rate where the error pattern is not present. However, this is a random and laborious process for finding errors. In our work, we introduce a machine-assisted solution where the tasks are reordered so that the tasks a machine performs well are front-loaded. A machine can very easily and quickly annotate and mine suspicious events, and then estimate the impact by calculating the escalation rate. This is done by comparing the outputs of the conversational AI agent's model in production to the outputs of an offline model. These differences in the outputs of the production model and the offline model are used to guide the data triage team on which sessions to inspect. We walk through how Alice, a member of the data triage team, uses our approach to find errors using our tool, DTTool. Alice begins at the Discover Issues page. It ranks the differences by escalation rate. The difference replace Coke with code means that to get from the output of the production model to the output of the offline model, you have to replace the word Coke with code. The right panel lists sessions with this difference. Alice groups by menu and notices that the differences are concentrated during the day menu. Alice then groups by course escalation type and notices that the customers are mostly initiating the escalations. Alice can investigate by clicking on a session, which navigates to the Analyst View page. The Analyst View page renders the conversation between the agent and customer for Alice to easily spot troubles. Lines of the conversations are marked where the differences occurred. Alice listens to the audio and hears that the customer actually said, "I have a code," but the model in production transcribed code as Coke. She also wants to see other instances of where this error also occurred in other sessions. The Similar Snippets panel shows where the error also occurred in other sessions. Please refer to our paper for more details on our tool and the qualitative evaluations we conducted with the data triage team. Thank you.